This video is about solving the limits using rationalization. All right, so you're given this problem, finding the limit of x approaches 0 of square root of x plus 2 minus square root of 2 divided by x times x plus 2. Okay, so now two important things. In the limit it approaches 0. Do we have a 0 on the denominator if we use direct substitution? Yes, right? So if you sub in 0 in for x here, the numerator will be fine. But the denominator, you got 0 multiply 0 plus 1, right? So denominator here, you have x times x plus 1. So if you sub x equals 0, then you have 0 times 0 plus 1, which is 0 times 1, or the 0. So yes, you have 0 in the denominator. So you can't really just sub the limit of x using direct substitution here. So there's a method that we call rationalization that you probably already read about. So what we want to do is to find a way to eliminating this x, because this is the problem here, right? This is fine, but this one is the problem here. So that what we want to do is that we want to, since we have a square root of both sides, so we're going to multiply the same square root from top and bottom, except for this going to be a positive, right? So what I mean is that I'm going to multiply top and bottom by the square root of x plus 2 plus the square root of 2, right? So let me put, so plus the square root of 2. And I'm going to do the same thing for the bottom, square root of x plus 2 plus the square root of 2, because doing this fractions right here is basically 1, right? Top and bottom is the same, so it's 1. So you're not changing anything. You're not changing the equation at all. So once I multiply this by this, since it's two fractions multiply each other, you can multiply cross, right? Just remind yourself in breakout, if A over B times C over D is the same thing as A times C divided B times D, right? So you can do a cross, except for if you do addition and subtraction, then you have to have a common denominator. Okay, so once you have that, you can multiply cross. So you have, I'm gonna show more steps so that you can follow. Limit of x approaches 0 of the numerator, you would have something such as square root of x plus 2 minus the square root of 2. That is this one right here, right? Put in the parentheses. Times the square root of x plus 2 plus the square root of 2. And the denominator, you have x times x plus 1 times the square root of x plus 2 plus the square root of 2. Now notice I put everything in parentheses so that you can see the separations, right? So now in the numerator, if you FOIL these out, if you do your foiling out, right? Whoops. Right? Then you will have something such as the limit of x approaches 0 of x plus 2, right? Minus 2 for the numerator. So I'll leave the foiling for you for your own practice. And the denominator, I'm going to keep the same for now, x plus 1 times the square root of x plus 2 plus the square root of 2. All right, so now look, for the numerator, since in front of this parenthesis, there's the plus sign here. There's no minus sign. So you can rewrite the numerator such as you can basically take the parenthesis out, right? Because you don't have to distribute the negative sign. So now the numerator, don't you see that I can cancel out the 2, right? Because I have plus 2 and a minus 2 that cancel out. So now my limit will be limit of x equal to 0 of x divided by x times x plus 1 times the square root of x plus 2 plus the square root of 2, right? So now the problematic x, which is this one, can be canceled, right? Because top and bottom, there's an x. So I can cancel that. So if once I do that, I have something such as a limit x approaches 0 of 1, right? Because the numerator now become a 1. If you remember, that's if you say x is the same thing as 1 times x. 1 times x is just x, right? So I got 1 over x plus 1 times the square root of x plus 2 plus the square root of x 2, right? So now the problematic x is gone. So it's like the troublesome is gone. Now you can do direct substitution, because if you sub 0 in for x, the denominator is fine, right? So that is approximately sub 0 in for x. I'm going to do sub 0 in for x. Then that approximately going to be equal to 1 over 0 plus 1, right? 0 plus 1, that's 1. The square root of 1 plus 2 is 3, plus the square root of 2, right? So that is just basically equal to 1 over the square root of 3 plus the square root of 2, right? So you can leave your equation, your answer as this is, or you can simplify it more. So now that is the rationalization methods that you basically see if your numerator have the radical, right? Have the radical, then you can multiply the opposite sign. So if this was a plus, then you could do a minus here. And if it's a minus, you do plus, right? So that's how the method goes. And one more thing, and notice that I carry down the limit up until the end, because it is important in math, because then once you get rid of the limit, you may forget what limit you're doing, right? So it is important to carry down the limit to show you when you show your work. Okay, so hopefully this will help.